Similar triangles. Do you guys remember similar triangles in geometry? And what did you know about the angles of similar triangles? What did you remember about the angles? Those are similar. So what do you remember about the angles of similar triangles? They're all equal. Good. If this guy is 50, and this guy is 40, and this guy is 90, then this guy is 90 if I say they're similar. But the sides are not equal, but the sides are what? Proportion. They're in proportion. So we can set up a proportion. So if this guy is, well, just for instance, if this is a 1, then this guy could be a 2. If this guy was a 4, then this guy would be an 8. It would be in proportion, right? Okay, so similar triangles, we have the angles are equal, the sides are in proportion. Now, my goal for this is that you realize your unit circle is just one of the many circles that we use, and your radius is 1. We can also put these angles on other circles that have a radius of 4, or 9, or 7, or 0.2, or 1/2. We can put them on any circle we want, and all of these angles will have the same, they'll be like your similar triangles, the sides will be in proportion. So if this is from 1 to 4, then all the sides are in proportion by a factor of 4. They work the same as your similar triangles. Now, we're going to start with your unit circle, because that's a good place to start. Your unit circle says your radius is 1. And the most important thing, and I draw this over and over and over, are the endpoints here. It goes up 1, out 1, over 1, down 1. Okay, I'm not sure if yours is labeled. Is it labeled? Yeah. This is 0 degrees. This is 90 degrees. This is 180, 270, and back to 360. In degrees. In radians, this is 0 radians. This is pi over 2. This is pi. This is 3 pi over 2. This is 2 pi. The key to remember this is 180 degrees equals pi. So when we start your circle, if we're on the unit circle, we start like this. It goes out 1, 0, 0, 1, negative 1, 0, 0, negative 1. This goes 0. This is pi. Therefore, the other half of the circle is 2 pi. What's halfway through is pi over 2. Agree? So I'm going by halves. A half a pi, 1 pi, 1 1/2. Oh, that's the same as 3 pi over 2, 1 1/2 pi. And it goes in a pattern over and over again. There's a pattern to your radians. And once you see the pattern, it's so much easier. A 45-degree angle. If this is 45, it cuts half a 90, right? So how many times does 45 go into 180? 4 times. Everything's based on your 180. This guy is pi over 4. Now, it's halfway through that quarter, right? So if this is 1 pi over 4, this is 2 pi over 4, which reduces to pi over 2. This guy is 3 pi over 4. This guy is 4 pi over 4, which reduces to, 4 pi over 4, which reduces to pi. See it? See the pattern? This is 5 pi over 4. 6 pi over 4, reduces to 3 pi over 2. 7 pi over 4. And 8 pi over 4. I'm going to look for patterns. It's the easiest way. That's how I do my radians too. I don't memorize them. I follow a pattern. Now, watch what happens here. The denominator is 4. These are the same because they cancel out to pi. Agree? This is 2 pi, so this is double, 8 over 4. So if you give me an angle, 5 pi over 4, I'm going to start like this. Oh, or pi over 4, double, 8 pi over 4. So everything rotates counterclockwise. So where would my 5 come? Right after my 4, wouldn't it? It would be in quadrant 3. That's my 5 pi over 4 angle. I want you to see patterns. It takes a while to catch these. It's the easiest way to catch your radians. Where would I find 3 pi over 4? What quadrant? 2. It's one before 4, isn't it? There's my 3 pi over 4. They work really, really nicely. Let me show you a 60, let's do a 30-degree angle. They're easier. Again, we're going to start like this. 1, 0, 0, 1. This is my unit circle. I'm 0, I'm pi, I'm 2 pi. Agree? And this is endless. This is an endless circle. When we unwrap this, that's what makes your curves, when we unwrap this. It's almost as if we tied a string around this and flattened it out and watched the numbers go up and down to make a continuous curve that goes on and on. Now, a 30-degree angle is right here. How many times does 30 go into 180? 6. This is pi over 6. So let's follow this rule here. This guy would be 6 pi over 6. I have to have it reduced to pi. This one would be what? 12 pi over 6. Okay. Now, you can go one step further. What comes between 6 and 12? A little bit more. 9. 9 pi over 6. Right? I would find it there. Now, if I say to you, well, okay, how many 30s come in 90? 3 30s in 90, right? So here's 1, 2, 3. Up and yep, that's a 90. 1, 2, 3. All the way through, it's a pattern. So if I'm looking for 7 pi over 6, what quadrant am I going to find it in? Third quadrant. Watch, it goes counterclockwise, right after the 6. 8 pi over 6. And I would really not look for 8 pi over 6 because it's reduced to a 60-degree angle. But what quadrant would I find it in? Between here and here, right? Which this would be a 60 degrees, so I really wouldn't be looking for this. How about 11 pi over 6? 4. Wouldn't it be 1 before the 12? How about 5 pi over 6? Second. Now watch. These are the ones that I need to find. They make a bow tie. They make a little bow tie here, just like your 45-degree ones made a little bow tie. Because what happens to this one and this one? When we found 8 pi over 6, what is this reduced to? 4 pi over 3. That's a 60-degree angle, right? So chances are we're not finding 8 pi over 6. We're going to find a 60-degree angle for that one. So all your 30s are going to be sitting right here, right like a little bow tie. We're going to do this a lot because I want you to see a pattern. Let's try a 60. I need you to think in radians. Again, 1, 0, and I'll show you why I do this too when we get to sines and cosines. This is 0, this is pi, this is 2 pi. I make this 60-degree angle. Oh. This is a 60-degree angle. How many times does 60 go into 180? 3. So this becomes 3 pi over 3. And what does this one become? 6 pi over 3. So where do I find 5 pi over 3? Fourth quadrant, right? It's 1 before the 6, right here. Fourth quadrant. Where do I find which we did before, 4 pi over 3. 3. And that also made us a 30 degree, one of our 30 degrees, but that's okay. We usually go by 60. Where do I find 2 pi over 3? Second, look, that makes a bow tie too. See the bow tie? There's another bow tie of all your 60 degree angles. They follow a pattern. See it? If you put this out here like this to reduce it, you double it on that side, it'll help you locate what quadrant they're in. Those are your special triangles. Your 30, your 60, your 45. Okay? Now, when we place them on the unit circle, it makes life a lot easier because we could also find the sine, the cosine at the 0, the 180, the 90, the 270, all the way around the circle we can find them on the quadrants. We call those quadrantal angles. And when we work on the unit circle, it's so much easier to look at these. If this is your x and this is your y, cosine and sine, cosine, sine. It's alphabetical. So if I'm looking for the sine of 0, the sine is the y value. The sine of 0 is 0. The cosine of 0 is 1. So much easier. X, y, cosine, sine. At 270, 3 pi over 2, if I use the radians, the sine at 270 is sine -1. Cosine, 0. So I can find your quadrantal angles right off your unit circle. I'm hitting you with a lot, but we're going to break these down one step at a time. But I want you to see the trick is not scary. It's just a circle, and all your angles rotate around the circle. And they're similar triangles, no matter what radius I use. Whether I use a radius of 1 and put it on a unit circle, I use a radius of 100 and put it on a bigger circle. The angles are all the same, and the sides are in proportion. So when we get to this, that's what we'll be looking at. Now, your concept of your unit circle, again, your radius is 1. And obviously your x and your y, when we make a triangle, have to be less than 1. Which is what you guys usually don't like to do, is make them fractions. Your trig functions, and this is going to be a little different for you too. I know most of you work off of this. We don't really use that in trig, because we need to use the x's and the y's. I'll show you a trick to convert this to x and y. Your sine was your opposite over your hypotenuse, right? Your cosine, adjacent over hypotenuse. Your tangent, opposite over adjacent. Agree? Okay. Now, in your SOHCAHTOA, you use these pieces. When we use your unit circle, or any circle, we have x values and y values, and that's what's going to help make your triangles. So we say sine is y over r. Cosine is x over r. Tangent is y over x. Now the reason these canceled out is because if you're on a unit circle and the radius is 1, then for any angle, the sine is its y value. For any angle, if you're on a unit circle. That's what makes it a special circle. And we're going to talk about those in a second. But an easy way to convert this is keep your sine, cosine, your tangent. Now, on your circle, when we do this, and we drop a triangle, your radius is what part of your right triangle? Hypotenuse. So all the hypotenuse is where your radius is. We have two letters, A and O. Put it alphabetical. A, O, X, Y. All the A's become X's. All the Y's are the O's. So the sine is Y over R. The cosine is X over R. The tangent is Y over X. I want you to see this in terms of Y, X, and R. not opposite, adjacent, hypotenuse, because we need to get the x, y's, and the r's. Okay. It's a little trick I came up with a few years ago. I had this student, probably 12, 15 years ago. He was from Buffalo, and I don't say Sokotoa the right way. So he kept saying to me, but you're supposed to say Sokotoa. It just never comes out like that. So he was from Buffalo. He learned a mnemonic for Sokotoa. Some old hippie caught another hippie tripping on acid. And don't repeat that to your parents, but it was something that stuck with me, and I've told most of my students. I mean, if you can't remember the mnemonic, it's not good to try to use it. Once you get that out there, this converts really nicely. Think of your unit circle, think of your hypotenuse, that's your radius, your A's, or come before your O's, your X, your Y, okay? So I want you to start thinking in terms of X, Y, and R when we do this. These are called your reciprocals. All they are is the reciprocal of this piece. And an easy way to remember this is this way. Your tangent and your cotangent almost look the closest, don't they? Tangent, cotangent. Notice they have different letters. So the secant and the cosecant have to be different than the sine and the cosine. Everybody always says cosine, cosecant. Cosine, secant. They have to be different. Sine, cosecant. That's an easy way to remember them. The cotangent and the tangent have different letters. So your reciprocals have to have a different letter than your sine. It can't have the same one. So it can't be the secant and the sine. It's the cosecant and the sine, the secant and the cosine. And all we do is invert them. This is R over X. Write this on your paper. This is Y over X. Oops, wait, sorry. This one has the X over Y, sorry. X over Y. This one is R over Y. These are how we look at these. They're reciprocals. We just take what the sine, the cosine, the tangent are, and we flip them over. We take the reciprocal. Okay. Now, sometimes when we solve equations and we do other things with the reciprocal functions, you can switch them around, especially on an equal, and switch both sides. So say you're looking for the cosecant of an angle, and we give you the cosecant is 3 over 2. You could take its reciprocal, the reciprocal for cosecant is sine, and find an angle whose sine is 2 over 3. It works the same way. You can change the reciprocals wherever you need to. I tend not to use the over 1 because then you have a complex fraction and you have to flip it over. So just take whatever's there and take its reciprocal. I'm hoping to get through just like the basic parts. Now, here's your basic angles. So I'm going to skip to this page and go to this one. Here's your basic angles. Don't think I'm going to put this in here. Okay. All right. I gave you 2 triangles. You only have 2 triangles that you have to memorize. And I'll give you my way first. So, here's your 30, 60, 90. These are not drawn to scale. So, well, let's make this your 45, 45. Well, let's make this your 30, 60, 90. Your 30, 60, 90. The easiest way to remember this so that you get all your functions are opposite the 30, that's the smallest angle, is 1. Opposite the 90, that's the largest angle, double it, is 2. If you add 1 and 2, you get 3. But that can't be right because the 60 degrees can't be larger than the 90 degrees. True? because the bigger the angle, the bigger the opening. So this guy is a radical 3. However you remember this is fine. If you have no way to remember it, this works. The 45-45, this is not a unit circle. This is just a regular triangle that you're going to memorize. The 45-45, the sides are the same. So 1, 1. Okay. We add this up, we get 2. This guy is a radical 2. Each one of these triangles has to have one radical in it. It can't be radical 1, because what is radical 1? 1. So it's got to be the side with the 2. Also, if this was 1 and 1, your triangle would collapse. A 1 and 1 would meet like this. You'd never make it into a triangle. You realize that, right? The two sides always have to be, the sum of two sides always has to be greater than the third. So that wouldn't work that way. Okay? Alright, these are your special triangles. Now, when we go to do this, and we put this on your unit circle, so I'm going to put a 30, 60, 90 right here for now. 30, 60, 90. This is going to be a 1, a 2, a radical 3. Easiest way to remember it is that way, not the one with the fractions. Now we're going to take this and make a similar triangle. God bless you. And I'm going to put this on a unit circle, where my radius is what? Unit circle, my radius is what? 1. So I still want a 30, 60, and a 90. This is a similar triangle. The angles are congruent, the sides are in proportion. So if I, God bless you, if this guy went from 2 to 1, I divided it by 2, right? So if I divide this by 2, I divide this by 2, I divide this by 2. 1/2, radical 3 over 2. There's your unit circle. I find it over the years, in the very beginning I was trying to teach kids from the unit circle, but I found it more difficult because of your aversion to fractions. So I think those are the two best ways to memorize your triangles, and then we put them on a unit circle. Now, even if you don't want them on a unit circle, you don't have to keep them on a unit circle. If you do this, and you say the sine, and we say the sine is y over r. If I'm on this triangle, there's my y, 1, there's my r, 2. Okay. Another easy trick is this. If I'm on this triangle, it's not a unit circle. Label your parts. X, this is the x value. Y, this is the y value. This is the radius. That's the only 3 pieces you'll ever need. Get it off the circle. So now, sine y over r for my 30 degrees. My y over r, 1 over 2. My cosine, x over r. Just use this little piece. X, radical 3 over 2. Tangent, y over x. Y over x. 1 over radical 3. You see where I'm getting them from? If I use my unit circle, because my radius is 1, my x is my cosine, my y is my sine. So on my unit circle, my y is my sine. Isn't that 1/2? My x is my cosine. Isn't that radical 3 over 2? But if you find this way much easier, I know I do, and over the years I found my students do because they don't like the fractions, put it on one of these triangles, pull out your information, and you can do the rest of this work. Now, here's your reciprocals. S has to go with a C. So I take this, I flip it over. 2 over 1. Secant goes with the cosine. I take this and I flip it over. Now here's the beauty of precalc. We don't have to rationalize any denominators. So remember last year you had to multiply top and bottom by radical 3 and get it out of there? You don't have to do that. Tangent, reciprocal for cotangent. Now you have all of your 30s there. Now, I can do my 60 as well. My 60, if you want to draw another triangle, I find it easier to draw the other triangle because it's a little bit more difficult for your 60 to do that because you changed your reference angle. Tonight, what I want you to try is this. I want you to try to take these two angles and I want you to try to fill in these pieces for me. Just the 30, 60, 90. These are your special triangles. Do what I just did with your 30. Do it again with your 60 and your 45. Yeah, I did this piece. Not the 90. The 45 and the 60 you have to do. Do the same way as you did your 30. Label your triangle and see where you go with that.